Today on Generally Engineered, we talk about materials and what to do when you're really not sure what to do. What is up, guys? Welcome to Generally Engineered. My name is Jacob, and today we are talking about materials. What do you do when you have a part and you don't really know what to make it out of? So we're going to go through 3 questions, I guess you can ask, that can help clarify that idea and get you the right material for the right job, for the right price, or whatever factor you really want. So the first question is, what do you want this part to do? Oh, thanks, Jake. Really helpful. Glad I watched this YouTube show. But really, it's a very important question to ask, right? And it can be very easily overlooked, especially if you're doing the quick and dirty. But taking a second to think about what this thing actually does, what your part actually does, super important in choosing what material to use. Is it holding up a super important structure like a bridge, or is it holding up a bird feeder? You wouldn't want a 6x6 wood post to hold up a bird feeder, right? So a lot of that is very dependent on what your part is actually doing. First and foremost, know what the part needs to do. It's super important and can help you keep from over-designing as well as under-designing if you have a very good idea of what exactly it is you need something to do. Maybe you need it to do a lot of different things. That's also an important factor to consider, and it will really change your choice of material and what things are good, what things are bad, and what things are completely off limits. The next thing I tend to ask when I'm trying to narrow down the choices are, what can we actually make it out of, right? If you're like me, a financially constrained individual, most likely there are limits to what you can actually manufacture on your own, and limits to what you can actually pay someone else to manufacture as well at a reasonable price, right? So you have to find someone to actually make the thing. So if you don't need it to be made out of lightweight carbon fiber, then maybe a simpler alternative will be better. So think about what you can actually do, what your skills are, what tools you have, because of course if you have to go out and buy another tool, that increases your price and you might not actually figure that in. So think about all those things. Have a really good idea of what you can actually do in-house. And that can take a lot of trial and error, a lot of testing, a lot of playing around, and it can also force you to be a little bit creative and think outside the box and come at something from a different angle. So definitely think about what tools you have, what tools you would need to do whatever it is, what experience you need to do whatever it is. If you're not an expert in machining and machine tools, then you might want to have someone else do that. You might want to call up a local machine shop to do that kind of work. So think about your capabilities, and that will help you kind of narrow down what materials you can choose from. If you have a lot of metalworking gear and not a lot of woodworking gear, then you might want to stick towards metal, and vice versa. Factors like that. Number 3 is the one that I think is fun and the nerd in me loves. You get to really look into the trade-offs involved in those different materials. Some materials are better at things than others. Metals are strong and ductile but harder to work with. Wood is a very great all-around material, but it's not the lightest, it's not the most efficient, things like that. So do a little bit of research and figure out what trade-offs are there. They can be between different parameters. It's whatever is important to you. The most obvious and most often used one, especially in automotives and things like that, are weight versus cost. You can usually get heavy things for very cheap or very lightweight things for very expensive. So it depends on where you want to be there. But you can kind of do this for any parameters that you want, some more easily than others. Obviously, cost is fairly simple. Weight is fairly simple, but things like how bendy something is, rigidity, a little bit harder to do. So you can do that, and you can do that in very broad strokes as well. You don't necessarily have to dig into the nitty-gritty math details that a mechanical engineer might. Understanding the broad strokes trade-offs might just be enough for you, and probably are enough for you. So it depends on how much you really want to dig into something, but usually a high-level understanding of those trade-offs will help you make that decision a lot easier, and it helps you prioritize what exactly you want out of that part. And finally, number 4 is making the decision. This is the not so fun part, but it can be fun. You just have to pull the trigger on something. There's a lot of ways you can do it, depending on how academic you want to get and how much time you have to dedicate to it. But at the end of the day, you have to pick one direction and go with it. A good plan executed violently now is better than a perfect plan executed next week, right? So that is maybe one of the most important steps, is not to drag your feet on deciding, and just deciding and going with it and trying stuff out, right? To summarize, if you're looking to figure out what material might be best for a part, the 4 things to do in that whole process are: understand what that part is doing very clearly, 2, understand your capabilities, what you can actually do with different materials, what materials are actually available for you to make the thing out of. 3, understand some trade-offs in it, in parameters that you're interested in, whether it's weight or rigidity or strength or cost. All those are important. And then 4, decide. Make a decision, go with it, try it out, and if it doesn't work, you can repeat. Hope this has been helpful. Thanks for watching. Do all the usual YouTube stuff, like, comment, subscribe. Really awesome. We'd love to hear your feedback on these things. I've been Jacob. Keep on making.